Hello, everyone. Thank you very much for joining. I am Abubakar Siddiq Ango, and I'll be talking to you about secrets. Can your CICD pipeline keep a secret? Secrets are so hard to keep. Yeah, as humans, we usually say one is private, two is company, and three is a crowd. Once something code there is exchanged with another partner, every friend has a friend. That information is already gone, and you have to no control over where it goes and how. But first, in terms of computing, what is a secret? In this talk, we are going to look at what's a secret and why it's so hard to keep, how most CI/CD pipelines currently handle secrets and its vulnerabilities. We're going to look at how you can use Vault with your CI/CD pipeline and the JOT authentication method. And at the end of it, I'm going to show you a demo of how you can use GitLab CI with Vault. First, what is a secret? Secrets are any credentials that you need to authenticate, authorize, or approve access to a resource. So this can be tokens, it can be API keys, it can be passwords, it can be certificates, it can be anything that allows you to authenticate, authorize access to something. Now, but it's very, very hard to keep secrets safe. It's not about if your secret will be discovered, it's when. And in the news lately, we've seen several stories. A simple search of on Google will show you different news stories of how secrets were stolen or how they were dumped by hackers. Now, why is it so difficult to keep secrets? It's because these days, we manage hundreds of unique secrets for various purposes. You have AWS keys, you have API keys for different services, you have passwords, and so on. Keeping track of them is difficult. Now, and multiple people need to have access to these secrets, probably for authentication or for deploying services. And again, we also want to use complex passwords because we wouldn't want someone to be able to guess our passwords. It becomes more complex. We can't remember them, and writing them down is definitely not advisable. So, and we've been advised very most lately to rotate our passwords very often, almost every time. But how do you rotate if every time you have to go to you have to create new complex passwords, you have to go to the services, change them, and so on? Manually rotating password is a lot of work. Then CI/CD. CI/CD is basically automation, and we love automation. Continuous integration and continuous deployment or delivery allows us to be able to build our projects, to be able to test them, and to be able to deploy them automatically. It's gone are the days where after writing your code, you have to test them manually on your system and then upload them through FTP or any other means online. Now, you can set up a CI/CD pipeline where just a little change in your code is automatically tested. It's automatically built, tested, and pushed to production staging or anywhere you want it to be. Now, most of these CI/CD tools, there are tons of them out there. Jenkins, Drone, Go, and so on, including GitLab CI. Almost all of them, if not most of them, use environment variables to be able to pass secrets to the jobs, the CI jobs. Most of them provide you with an interface where you specify the variable name for each of the environment variable, and you supply the secrets that you want to be held in the environment variable. And to be able to protect these secrets, some of the CI/CD pipelines mask the variable so that it won't get exposed. But we are humans, and we are usually weakling in this kind of secure systems. What could possibly go wrong when using secrets with CI/CD, especially when you're using environment variables? First, expose secrets in job logs. there has been a ton of incidents where hackers comb through the job logs, especially job logs that end up being public. Those that are not being public, when probably a CICD provider is hacked and they are able to get access to these job logs, they comb through them to discover any secrets that have been exposed. And secrets are usually get exposed by either echoing them or using them as part of a URL request, and it ends up being shown. A lot of the CICD providers provide a means for you to mask this password, but it's even with the masking, someone can still get access to the password if CICD provider is hacked. Now, I provide here an example of a news article stating some of the recent incidences where hackers are combing through CICD job logs to steal any exposed password. Now, the other major thing that could go wrong is privilege escalation. Yeah, even when your password is masked in a CICD provider, the next thing is your employees or developers who manage the job, who write your code or manage your deployment. When a secret is kept in a project or a level where someone who is not supposed to get access to it gets access to it, even if it is masked, they can easily take this secret and do whatever they want, especially when you have this disgruntled employee or you have an employee that's recently been sacked and he really wants to do some harm. So the two major things that could go wrong with using environment variables and CICD is secrets getting exposed and privilege escalations. Secret getting exposed, a lot of the CICD providers are now providing a tool or a means or some mechanism. For example, like Travis CI, when they discovered hackers are combing through logs to discover this, they decided to create a logic that checks the job logs to see if there's any pattern that is similar to a secret, and they mask it or obfuscate it. So other providers like GitLab provide you a means to mark your secret as masked, so that even when it's echoed or displayed or an instruction is trying to display it in the job logs, it only shows masked. Now, the best kept secret is a secret that doesn't exist. But how do you create a secret that doesn't exist when it needs to be used? That's where you have things like dynamic passwords, passwords that only get generated when they are needed. And as soon as they've been used, maybe once or after a particular period of time, they expire and they are no longer needed. And constant rotation of password. The password is created today, maybe by midnight, it has been rotated by midnight. So it's very difficult for a password or a secret to stay too long without it being replaced. This allows an organization or a company to be able to make sure their passwords are always fresh, and they are, for anyone to, like a disgruntled employee, to want to have and keep a secret to harm the organization. Probably by the time he gets home, the passwords have already been rotated. It might be all the secrets within the organization. And that way, the organization has no secrets while having secrets. Now, the best solution to be able to effectively manage secrets is to use a secret management tool to provide you with a secure secret management, constant rotation of secrets, and data encryption. And one of the major players is Vault. It's Vault. Vault gives you a very robust and secure way of managing your secrets, including data encryption. It also comes with a data encryption API that you can use to encrypt any data that you want. Now, one of the beauty of it is you don't need to start coming up with any new identity management system. It can readily plug to any identity management system you have and help you manage your secrets effectively. Now, when you're using Vault, you need an authentication method to be able to authorize your users whenever they want to request a secret or put a secret. And one of the ways you can do that, some of the ways you can do that is by using a username and password, or using AWS if you already have, if you are using AWS as your identity provider, or GitHub, Radius, Okta, and a number of them. But the one we'll be focusing on in this talk is JOT and OIDC, OpenID Connect. Now, the JOT method allows you to use a tool, for example, like GitLab CI or Travis or any other CICD, to send a JOT to Vault, and Vault authenticates it and provides the token that is necessary. So there are two ways. You can either use JOT, which is authenticated using OpenID Connect, or you simply provide the JOT to Vault and it authenticates the user. One advantage of using JOT without OIDC is it can be simplest without any user interaction, but OIDC will authenticate against an identity service provider like Auth0 and so on. But you wouldn't be able to use that. That won't be effective for a CI because everything needs to be automated. But with just using a JOT file, sending a JOT token, it's no user intervention is necessary. It simply sends it to Vault. Vault authenticates, moves on. Now, how does Vault authenticate your JOT signatures? It can do it in three ways, either by you providing Vault with the static keys it needs to authenticate the JOT token with, or you provide a JSON web key set URL, where anytime Vault receives a token, it sends it to the WebKit set URL, and which authenticates it and responds back to Vault to provide the token. Or you can provide an OpenID Connect discovery URL. But for our case here in this talk, we'll be looking at using a JSON web key set URL. Now, when you are creating your JOT signatures, one of the ways that you can use to limit or authenticate, authorize who uses Vault to access secrets is by creating bound claims. You can say, for example, okay, this CICD should only be authenticated to retrieve secrets if it's for a particular project, a particular branch, and there needs to be a user, or and so on and so forth. You can even go as far as saying production keys should only be accessed by a job being run on the production branch of your project. And staging should only access keys from the staging keys that are already stored on Vault. Now, this is a diagram showing how the JOT authentication happens. Now, when you are running a CI job on, for example, GitLab CI, it automatically generates a JOT token containing all the necessary information needed for Vault to authenticate the request and sends it to Vault. Vault then communicates with the GitLab instance using the WebKey set URL to verify, is this token still valid? And the claims that has been listed in it, are they correct? Are they valid? If everything is fine, then it creates a token and sends it to GitLab CI. Now, the token has a TTL, time to live. By default, if none is specified, it's 5 minutes. Or it uses the TTL of the CI job, the timeout time of the CI job itself. As soon as the job is completed, the token has expired. So this way, no token lives further than it's needed. Now, I'll be running a demo of how you can do this on a CI/CD service like GitLab CI. First, to do this demo, we'll look at the JOT payload that is created by GitLab in the first place. Now, for every project, GitLab CI creates a CI underscore job underscore jot environment variable and provides it to the job. Now, and in this variable is a jot that contains every information that Vault needs to authenticate the request. Now, first, aside from the usual jot data that are included here, we can see a namespace ID. This is, okay, if a project that you are trying to work on GitLab belongs to a particular group, GitLab provides the group ID, it provides the group path, it provides the project ID, it provides the part of the project, the ID of the user who is running the job, the email of the user running the job, the pipeline ID that is currently running, the job ID that is currently running, the reference of the job, which is usually the reference that is used to mark the job that is running, and what is the reference type? Is it a branch or what is it? Now, then also if the branch is protected, here the ref type that GitLab sends is a branch. And within GitLab, you can specify if a branch is protected or not. So if a branch that is not protected is running a job and tries to retrieve a secret, it will fail because we already specified here that it's only when the ref, which is a branch, is protected, that is when a request should be authorized. Now to enable JOT on Vault, one of the first things we need to do after you've installed Vault, unsealed it, and so on, is to enable the JOT authentication method itself by simply running vault auth enable JOT. Then we will now write the configuration for JOT using CMD. You can also do this in the Vault UI. Now, in the configuration, we are going to specify to Vault that our JSON web key set URL is gitlab.com/jwks. And, oh, a little mistake there. I put double dots instead of single dots. Now, then the bound issuer is gitlab.com. So any issue authenticates that this request has to come from gitlab.com. Now, we also need to create access policies. For this demo of mine, I have a GitLab project that has two branches, the master and production. I'm using the master branch for my staging code and the production branch for production. So I'm creating two policies here. One, the first policy is for staging. Anytime any password is accessed in the path kv vault demo staging, if any staging secret is accessed, it should apply, it should only give it the capability to read. Now, if any secret is trying to be read from the production path of my keys, it should apply the staging policy and only give it the read capability. So if a request is being made for a secret and probably is trying to access production keys and specify the staging policy, it won't be able to read it. Now, then the next thing we need to create is roles that will link our JOTs to the access policies we just created. The first one I'm creating for staging, and I'm specifying that the token that will be created should only last for 60 seconds. Now, and also the user claim should have user email. It should be this specific project ID. If you remember in our JOT, GitLab sends the project ID, the ref, and also user email and all the information that is necessary for you to authenticate. So now in our role here, we are saying we'll be checking the user claim should have a user email, and the bound claims must be this project ID. It must be, the ref type must be a branch. If it is anything else, we are not accepting. Then it must be master for staging. Then for production, we are creating production for role also, which all uses the Vault demo production policy, has a TTL of 60, and also this particular project, the ref, which is the branch, should only be production. Now, once we've done this, this is an example of a GitLab CI script. And what it does here is it uses the Vault Docker image and creates a job called read secret. But this job only runs for ref production. That means the production branch. Now, the first thing we did here is to echo the commit reference, just for diagnostics, is for us to see exactly what it's doing. Then we specify the vault address, which is here. For in my case here is vault abango.me port 8200. Then we request a vault token. From here, you can see we are saying request a token from our vault with the role vault domain production using this jot from provided by GitLab. Now, once it does that, it authenticates and authentication goes smoothly. It retrieves the password in the field key from the path production API. Then it echoes the password. Now, we also try to show that if we are now using, trying to access the API key that is stored in staging, it will fail because this branch is for production. The same thing goes for when we are trying it on staging. Remember, we said our staging branch is master. So we use the staging role to retrieve our vault token, then retrieve the staging API key. But if we try to access the production key, it fails. Let's see this in action. Not going anywhere yet. Now, this is my demo project, and this is the GitLab CI file that I have. Now, just like you saw previously, the CI file has two jobs. First one is to read secret, and it only runs when you merge or push to master, which is, in this case, is our staging. Now, the second job only runs when you push to production. And the production job uses, let me zoom in to make this more legible. Awesome. Now, like I started earlier, the first job only works when you match to master, and it uses the Vault demo staging role that we created to retrieve a token, authentication token, Vault token from Vault. While the second one, which is which only works when you merge or push to production, uses the Vault demo production role to retrieve a secret, to retrieve the Vault token, and tries to access the production API key that it needs. If it tries to access staging, it fails. Now, let's run this as a CI pipeline and see it in action. Now, I run pipeline now. Yeah, this will simulate, okay, merging to creating a push to production to master. Now, let's run this pipeline. It will create a job called read secrets. Now, in this job here, I already have my Vault instance at vault.abango.me, and I've created all the policies and all the policies and roles needed to make this demo much faster. Now, this is pulling the Vault image from Docker Hub. And as you can see here, based on our job, we said it should echo out the CI job jot, but it's maxed. GitLab maxed it, so it won't appear. It's one of the ways you can protect your environment variables. Then it commits our ref name, its master here, and it's protected. So it tries to, it sets the vault address to our address here, and it tries to retrieve the vault token, which is authenticated. If it failed, it will have logged here that it failed. After accessing it, then it retrieved the API key for staging and displayed it for us here. Now we tried retrieving the API key for production. It failed because permission denied. It's not authorized. Why it's not authorized is because we locked in with the Vault to demo staging role. Now, let's run this pipeline again, but against the production branch. Now, I was specifying the branch to use here, which is production. And I will run the pipeline. Now, it will create a read secret prod job. And that job only has the role for production. So it will now fail when you're trying to access the staging secret, but work for production. Now, as you can see here in this talk, we've seen how, now, you can see here, it was able to access our production key, but failed when I'm accessing staging. Now, you see here, we have been able to use GitLab CI or any other CI tool that you're using to access secrets that we are authorized to get access to, using a token that only lives for the duration of our job. So here we have secrets that don't exist. Because even the secrets that are in the API that are involved can be rotated at any time, or can be dynamic secrets that are automatically generated when requested. And as soon as you are done for one time this, it's gone. So even if someone picks a secret here, they cannot use it again. Now, for purpose of this demo, I decided to echo the secrets I'm retrieving from Vault, but it is not advisable, or you shouldn't or never display your secrets in CI log. Thank you very much for joining this talk. I'm happy to take questions in chat, and you can follow me on Twitter at Seriki247, and also you can check out my website abuango.me, so we can share more and collaborate. Thank you very much for joining.